With the building season's intensity and the innovation needed to engineer a successful robot, the first robotics competition is always an immersive experience for everyone. To amplify this, and to expand on our enthusiasm for robotics, we created the ShortyBot. It's without doubt one of the best robots we have ever built, along with many innovations across many spectrums. We focused on the features that matter the most to the competition, and we made huge leaps. Right off the bat, the robot's drive system are tracks, which are custom built. For protection purposes, the motors are sealed with bent sheet metals. The front portion of the tracks contains a 30-degree slope, so the robot goes over the defenses with perfection. By not purchasing regular parts but by designing components from scratch, we can create a robot that caters more to the needs of the competition. And our dual-purpose intaker is another example of our designing power. One compact motor rotates the roller, which rolls the boulder in and out. Resting on the surface of the inner beam is a pressure sensor. When the ball is rolled in, it impacts the pressure sensor, which creates a feedback to the roller reel that stops the roller. To allow more grip on the boulder, the stopping mechanism has a 15 milliseconds delay. This integration with the pressure sensor allows the robot to pick up the ball with exceptional accuracy. The intaker is also driven with two pistons, which raise and lower the intaker. This feature allows the robot to drive over defenses such as the Chevaux de Frise with ease. The ShortyBot contains not only hardware innovations but also software breakthroughs. Due to the complexity of the defenses, the robot ends up in random directions after going over defenses. To compensate for this, we created a driving mechanism that corrects the directions automatically by taking full advantage of the gyroscope. The mechanism contains a 3-level correction algorithm. If the robot deviates within a 2-degree angle, we neglect this and allow the robot to go straight. When the deviation increases to 2 to 8 degrees, we set the robot to turn slightly to the opposite direction. When the deviation is greater than 8 degrees, the robot turns quickly to the opposite direction in order to drive in the correct direction. We have fully emphasized on teamwork to create this year's robot. Mechanical team, electrical team, programming team, and designing team have to work in conjunction with each other to deliver the best results. For example, to enable the functionality of the motors, the designing team has to obtain the measurements from their design of the robot, so the team knows where to mount those motors. Then, mechanical team bears the responsibility to adjust the gears to drive the motors at maximum efficiency. After that's done, the electrical team hooks up the wires and reports to the programming team about the roller reel ports the motors are hooked into. The motors become fully functional afterwards. Therefore, our team cannot build a robot without collaborating with each other. The result of all these collaborative efforts is a robot that goes over almost every single defenses, drives incredibly smoothly, and shoots the ball with exceptional accuracy. The ShortyBot seems to be a complete contradiction because it's just under 16 inches tall and it weighs just under 93 pounds. You know, it's lighter than me. None of our previous robots comes close to this type of performance. And our fundamental goal in designing the ShortyBot is to accommodate as many features as possible within an incredibly short profile.